Hello and welcome to this session of BCD addition. Let's first check how decimal numbers are represented in BCD format. As you can see, it's quite similar to the binary representation. Hey, but wait, it's okay till decimal number 9. A nibble is a string of 4 binary digits, and each decimal digit is represented in nibbles in a BCD number. So, binary representation of decimal 10 is 1010, and it's okay. But if decimal 10 is represented in BCD like 1010, it will be wrong. So how would decimal 10 look like in BCD? Just consider 10 as 1 and 0. First consider 1, convert it into binary and then represent in nibble form, that is 0001. Next consider 0, convert it into binary and represent in nibble, that is 0000. So decimal 10 will look like this in BCD. Not only 10, but any decimal number having more than one digit. If each of the digits are not represented in nibble, the BCD representation will be wrong or illegal or not permissible. Now let's add two decimal numbers. Say we want to perform the BCD addition of two decimal numbers 168 and 779. So let's first convert decimal 168 to BCD. Again we consider 168 as 168 and represent each of them in nibbles. So the final result for 168 becomes like this. Now convert 779 to BCD. As usual, we consider 779 as 779 and represent each of them in nibbles. And that final BCD representation of 779 will look like this. So what we have to perform is the addition of BCD representation of 168 and 779. Now BCD addition is performed by adding two digits of binary, one from each, starting from least significant digit. We will consider each nibble set as a group. So let's start summing with rightmost group in binary. But this group sum generates a carry 1 if we take a nibble from the last part of the result. It can be taken as a rule of BCD addition in case if the result is an illegal or not permissible in BCD, or if there is a carry out of 1. Then need to add binary 0110, which is decimal 6, and this is to be added to the initial sum, and add the resulting carry to the next most significant digit, which is the least significant digit of the next group. Now focus on the result of the sum of the first group. 0001 is decimal 1, and this could be considered as the result if we omit the carry 1. But since 1 is the carry out here from the rule of BCD addition, we have to add 0110, which is decimal 6, to the result sum of the first group. So let's perform the sum. The last nibble is 0111, which is decimal 7, and that is a permitted code. Here from the result we'll consider the last nibble as the main sum of the first group. The carry 1 is to be added to the next group. Now we focus on the sum of the second or middle group, where 1 is the carry from the first group. Wow, the carry out is 0 for this middle group sum. But alas, 1110 is illegal code in BCD. And it is illegal because 1110 in binary is equivalent to 14 in decimal. So again we have to add 0110, that is decimal 6, to the result. Let's perform the sum now. Here the last nibble 0100 will be considered the result of the sum, and the carry 1 to be added to the next group. So looking back to our main sum, we find this. Now focus on the sum of the third group. Here 1 is the carry from the middle group. Now the result 1001 is permissible and it has not generated any carry. So it is consequently the final result of our main sum becomes like this. We can verify it this way. The decimal sum of 168 and 779 becomes 947, which is perfectly equal to the BCD representation of 947 as we obtained from the BCD sum of 168 and 779. So this is the final BCD sum. Hope you have enjoyed this video. Thanks for watching.